Yeah, hello everyone. I think it's been a while, and thanks Neo4j to giving us the platform. So let me quickly share my screen and start with the session. I hope I hope it's visible, right? So the idea here was that we were working with a client who currently dealing with in real estate projects, and they're pretty big, and they have been in the industry around 30 to 35 years. Throughout the time, they have acquired a lot of information in terms of documents, building materials, plans, approvals, certifications, and all. And they came to us to make sure that these previous research and previous documentation which they have done, it's somehow yeah, somehow actually curable, so that anybody can ask questions around those specific information and get the answer accurately. So before we actually get into the implementation and part, I kind of wanted to give you a little bit that how a typical real estate firm or company or a builder operates in India. So so first thing they have to do is they need to identify a land where they are going to build or deploy their project, right? So it could be any specific locality within their area, or some expansion happening from the authority side, and they give the land on a specific type, the type of use, and based on that use type, multiple builder can apply for their project, bidding and all those specific aspects. So this one is like when builder identifies a land. After identifying the land, what he has to do is he has to create these important documents: the lab feasibility report, the zoning and land use plans, and so much other specific compliance and necessary documents. Once this document is done and it's submitted, the next phase is where they're going for in a specific internal bidding. So multiple builders want the same land, and then authority has no way to award one of them, so they conduct this particular bidding. In the process of bidding, they also generates a lot of documents, like they have to have some specific application form which will be created, and a particular project feasibility report has to be submitted. Their financial statements are needed, and a portfolio of their previous projects, which also plays a very important role in order to get the bidding basically awarded. After that, there is a review and scrutiny process happens. In this particular step, what happens is that authority and builder talk to each other on a various stages. They ask a multiple documents to be submitted, and once that happens, these are the core documents which they actually submit: detailed project report, that what builder is planning to build on that, what would be the environmental aspect of that particular building or that particular digital construction or project they are doing. uh, do they have land ownership proofs throughout the channel? Because in India, land ownership is a little bit tricky. Like, it should have a whole history of basically ownership, which people buy and actually sell the land, and any specific correspondence which they have done throughout throughout the process. So this means that they have to maintain these specific important documents in this process, so that their review and scrutiny can get done. After that happens, they need to go on various government agencies to obtain approvals. What these approvals are like: you have to go and take approval from your environmental department. You have to have somebody, some agency who can approve the building plan you are basically planning, and you also have to create a very detailed architecture plan, which shows that how your structure integrity gonna be, how, basically how you are planning to make sure the water is distributed, electricity is distributed. All those specific detailed building plan needs to be added. Structural engineering and all those specific other things. And also you need to obtain no objection certificate. And this is very important, because if any department holds you in this particular space, then you will be stuck in you as a builder or as a real estate company will be stuck here forever. After that, what happens is that the agreement and allocation happens, and there's a lot of documents created in this particular stage as well. And at last, you get the registration and possession. So this is one where first part of the job for a real estate company is done, right? They get the ownership of that particular that particular land. They get the plan which they want to build or the project they want to build on that land approved, and then they move to the next stage. And this stage also they have a lot of documents coming from authority, lots of documents they had to prepare and submit to the authority, and after that what happens is that there's a process of uh, basically construction and development. The construction and developments happens in a way that you need to make sure that whatever you are trying to build is easily understood by the buyers. So you have to create a lot of documentation and lots of plans and all those specific around, and also some specific buyers or some specific people also need to see some of the approval and documents you got, so that they don't they don't feel that they are actually getting into a trap or something like that. So all those things needed to be done till the time they get the occupancy certificates for that particular land or for that particular project. There's a tons of data and tons of documents they have to create. After they get the occupancy certificate, then what happens is the handover happens. Handovers means the in normal day-to-day trend we call the registry of the project, or registry of the flat you are buying, or registry of a shop you have bought, all those specific things. So in this also they create a lot of documents like handover documents, registry documents which allotted from the authority itself. There's a maintenance agreements need to be made. If there is an out, if there's a warranty or all those things needs to happen, those also should go. So what I wanted to get an idea that how massive the scale here for a single project, right? How much data they have to generate in order to get through for one single project. Think about a situation where a builder is doing business for 30-35 years. How much of a data that builder could have generated, and those data are sitting idle somewhere in their repository, and nobody is making use of that particular data. So the pain was that how we can use an optimized method by which they can search this whole information, because these information are sitting in PDFs or some specific in a format which is not readable directly or searchable directly. You have to go find individual documents, look for them, and then only you'll read them, and then and you get the context. So building a knowledge base was something which was very necessary at this stage. So typically in situations like that, we have two specific aspects, right? One, we can go and train our own, essentially a model, and the other one is that we can go and build something on top of context using any LLM model, define a context, and then go with that. So this was the same. So that was the story, that what this particular talk is all about. I thought I also present a little bit about me. So hello everyone. My name is Ashok Vishwakarma. I currently run a company called Impulsive Web, and I have been in technology for I think almost 17 plus years, and I happens to be a Google developer expert for especially web technologies. Uh, so coming back to the original plan, right? So there are certain expectation which we had when we started looking at this whole ecosystem. So the expectation were that we need to make sure that the answer which our system is generating is accurate, and it should be relevant, and it should also be scalable, because see, the builder is not going to done with this particular projects he have done. He keeps doing new projects, and that gonna add lots of new documents within the ecosystem itself. So scalability is very important aspect here. So if we go with these two individual solutions which we identified, if we take the first one, right, where we think, okay, let's train a model. I'm just giving you a certain nuances to understand why we have rejected this particular idea. So it's very I mean, there's a benefits to it as well. Like you can have better quality results. You can have n number of examples on which you can train your specific questions and specific queries. You will be saving tons in tokens, right? I mean, there's a limitation around that, and you'll also have very less latency compared to what a context-based system will give you. So, and this is how you do it, right? You create these prompt and compilation pairs and in a specific document and give that to your model, and then you train that particular thing by using multiple tools. But the problem with this approach is that, which was very important, is data privacy. So once your model is trained with all this particular data, you have no control on that particular data. Anybody can have that model and get the knowledge from your project. And for real estate companies, their data is sacrosanct, so they cannot share the data. They have n number of authorization layers within the company itself, that who can see what. So building a model was not that much of a sense, because the data privacy was not that much available in that particular solution model. The second problem is because as you train a particular model, you need lots of resources and all, and that is very expensive to do. Scalability was another challenge. Like each time new projects are being done, we have to go and train the model again, right? So that was not something which was very scalable in the design itself. And then there's a lot of manual effort requires, right? Each time a new project happens, somebody has to go and create those prompt and compilation pairs. So I don't know, given that much information, how much resources you require in order to get this prompt and compilation pairs generated. So the second option, so we resort to the second option, right, where you can use the context, right? So benefits are pretty much like you can have data security, because your actual data and your LLM are two separate entities, and you can define what thing can be accessed by who depending on their login or their other specific information, and then you enable that portion of your data to extract the context, right? And it's also a bit cheaper, because you don't have to go and spend so much money in training the data. And it's also be scalable, because as soon as your new data is coming in, what you have to do is just whatever data ingestion pipeline you have created, use that, and then send the data inside your specific specific context database, or any specific database which you're using for your context extraction. The best thing was that this whole thing can be automated, so there is no manual effort, right? There would not be people sitting and writing prompt and compilation pairs, so that reduces the manual effort completely. A simple example would be like when you send your prompt to an LLM. What you need to do is you just define this particular structure, that okay, using this context, add your context, answer this question, and the question is something which your end user is asking, and then LLM can use the context to process the information. But there is also certain challenges in this particular ecosystem. The first one is the token size limit, right? So here is a list of models which are very popular, and these are the number of tokens you can send in single prompt. So when your database grows that significantly, you're not able to send everything into a single context, right? You need to have some form of extraction in basically enabled, and this is where because of these limitations, the direct approach of context doesn't work. It also responds very slow, because as much your context grow, first the model has to process the context, build a particular knowledge base, and then it need to process the basically process the specific query. And one second, sorry. And then you also have very limited accuracy, because the context you are sending may not have the related information of the query people is asking. So you're not doing in all that specific accurate space, and that's where the So the goal here is that we can have smaller and accurate context, some mechanism by which we can do that. And that's where, RAG is very important, right? Retrieval, augmented generation, and on that. So it's a simple definition, like you have an external database where you are keeping all your context. By whatever user is querying, you just querying that particular external database, and getting the accurate response by sending the limited context related to your specific query only. And an external database could be a vector database, a graph database, whatever is suitable based on your specific needs. What it gives us that it optimizes the search, so you don't have to pass all the context every time. It's also has to have some way of efficient basically context extraction, so that your relevancy is intact. And then also you should have to generate the responses. It should increase the accuracy of your responses, so that if I'm asking a specific question, the answer should be very specific. Hallucination and all those things should be reduced as minimum as feasible. Um, and RAG is something which helps doing all those specific aspects over there. How it works, I don't want to go too much into the details here, because I think there is a lot of talks which explains how RAG works and all. But yeah, I mean, I'm just giving us, you have a simple, so this is a very simple mechanism of your data ingestion pipeline, that every time your new data comes in or your existing databases will converting into into queryable database. You have a text, you use some LLM to convert that text into a vector, and then insert that vector into a vector database. As simple as that. What it does internally is, if your vector database is intelligent enough, it's kind of based on properties and data you're passing. It's also create clusters, so that similar information groups together and they're easily to find. Everybody knows how actually graph works, right? So this is something from there. And when you are extracting the context, what you do that it's whatever query his user has typed, that you send to an LLM, get the vector out of it, and then match that vector against your vector database, and you get certain nodes out of it. So based on your cluster, maybe this is a representation that how the matching node is supposed to work. And then using that query plus context, you send that to an LLM, and LLM generates a response. It's as simple as that. So this is how a RAG works. Initially, what we did was we took Gemma as in our LLM, and MongoDB as in our specific database. So the reason we choose MongoDB was because it was familiar with everybody in the team, and there was existing project for that particular company which we're building that was in MongoDB, but for a different use case completely. So we thought, okay, let's give it a try. And there were tons of challenges with it, right? So I have categorized that into specific three categories. So one is the data structure, right? So in MongoDB, what happens is that everything is stored in a collection and a documents format, right? So your vector or your graph will also be stored in the same fashion. So there is no native implementation, and that is a big challenge, and that also is it in the presentation basically why. The other one is the query mechanism, how you are extracting information from the database, how you are you know uh, querying the data which you have stored. So in MongoDB, what happens is that there is a thing called brute force KNN. What it happens is that, so every time your MongoDB's KNN algorithm searches the closest vectors, and it kind of do by computing a pairwise distance between two specific vector, and it has to do that in all stored vectors every time. So there is no a mechanism by which you can optimize this. So every time you run a query, you'll have a minimum of basically O(n) complexity. It goes beyond that as well, but this is the least you can hit. And that was a situation where getting the relevance information. Yeah, as I mentioned earlier, that relevance is very important when you are thinking about RAG and all, and that's where it was kind of setting us a little bit back to get the optimization which we needed. Also, the scalability was a challenge, because it's not as similar to the graph like relationship when we talk about in a relationship between the nodes, and it does not optimize that. So every time we have to add a new data, we have to do some sort of manipulation and data transformation in order to put the data into the MongoDB. And then we thought, okay, I mean, we have expertise in Neo4j. Let's form a specific small team and get this thing translated for a very small space and see that if there is an improvement, and then based on that we can decide that if we have to change the underlying data layer completely. So the first thing, comparing the data structure, Neo4j is native graph, so you don't have to worry about documents, collections, and all those things specifically for your data. And it's also have a very good query mechanism. So instead of using brute force, it has lots of graph storage visual algorithms based on case. In certain cases, it can improve the performance. So this is a very simple HNS SW example here, which simple let you navigate your graph in a very simple way, and the complexity you get out of it is O log n. So it's a uh, it's a logarithm approach when you have multi-hop algorithms. I mean, there's a lot of details you can read about it on Neo4j Neo4j website as well. But yeah, this is something which, so thing to understand here is all ON versus O log n, right? So this is the benefit you get when you actually move from Node.js, from MongoDB to sorry Neo4j. Scalability is also solved by default because you have high dimensional, connected graphs, and it is optimized by architecture itself that it can hold and store, a tons of information. So this is a pretty much very small comparison, I would say, that how MongoDB vector, which we have implemented, and how Neo4j, the study which we have done, how this compares in an actual environment, right? So the data model, the query approach, handling responses, scalability, and performance. What we saw that in by using Neo4j, our query responses were 10 times faster, what which was earlier using Mongo for a similar sample of data. It was when it's a multi-hop query, it was 100x faster compared to, because MongoDB does not have that optimization on the algorithms. And in Neo4j, you can also implement your own algorithm that how the traversal actually happens. It's also we also have saved a lot of money and resources in terms of storage, because the way MongoDB stores information and the way Neo4j actually store information is drastically different. And we also have reduced a lot in latency in retrieval, latency in traversal, and all those specific aspects around that. So this was the end result of that particular case study, from going from, and this made us think about moving from MongoDB to specifically Neo4j. We also thought of, because this has given us a tool and a pathway by which we can also incorporate lots of other enhancements in the future, which was not possible earlier. So I thought, okay, let's talk about those ones. So we're also thinking to invest a little bit on much more relevant and data processing pipeline, where we have the cleaning, segmentation, metadata encapsulants, and enhancements, and all those things also added into the pipeline. We also want our vectorization done in batch. As of now, every time it's go into a very serial approach, and we also have to look through certain solutions there. Batch processing can happen so that we can reduce the time from a document being created to it's available to query, right? And we also have to think about various tools and techniques by which we can further optimize that our specific vector which is generated by Gemma as of now. Storage, we also thinking to as much more in strategies around that in terms of indexing. I mean, as is grow, we also have to think about archival and distribution processes. So we also started jotting down those specific information, that what is needed, what is not needed, based on the people are querying, what information they query more often, all those specific things. As of now, what happens is that our query is very straightforward. It does not have any contextual understanding. So we're also building a separate layer on which whatever previous information you're querying, that is available, and it's based on that our context is manipulated a little bit, so the information, the responses you're getting is much more accurate and in line with what you're talking. So that's something we actually want to add, and we also want to collect some feedback from the user that whether their query is resolved or not. So a loop where we can improve further. We also want to do some specific ranking, maybe some hybrid retrieval. I mean, that's something which is very far-fetched just now, and we have to see whether we'll be able to do that or how much time and effort it will take. We are a little bit on that. As of now, all responses are pretty much what actually Gemma gives us, right? So we also want to have some sort of personalization templates and some sort of mechanism to handle responses when we are not getting them correctly. So all those things need to be done. And yeah, if you want to read further about this stuff, you can read about Java. If you want to get started with Neo4j as quickly as possible, I would suggest go with our RDB, because that is what we started on. We created an account and it was 15-20 minutes setup, and all our basic graph layer was done. And if you want to read more about these kind of things, here is my blog. So I think I have 3 or maybe 3.5 minutes left. So if there is any questions, I can answer that.